Hello, I'm back. All right. I'm sitting along in the car, sitting next to my husband, and he's blaring Oasis. We saw Oasis in Toronto to a couple of weeks back, a couple of Sundays back. My husband, this was the experience of, one of the experiences of his lifetime. He loved the fact that the two brothers, but I also talked to estranged brothers who had not played together from so many years. And getting together was like a fact to be celebrated. The crowd went haywire. Toronto was in, raptures over the Oasis. I liked them, and I danced for a bit and everything. But it began to rain and it got cold. The summer night, it got cold. So the opening act was also good. Opening act, I thought it got a line, something elephants. Yeah, the song was elephants. Got my own line. Well, yeah, the tune evaporated. It just went out of my mind. And so coming back, and I got the thought that entropy and enthalpy could be, centered around a partial differential equation. You all know the Gibbs free energy equation. Delta G, change in Gibbs free energy is equal to change in enthalpy, delta H minus temperature multiplied by change in entropy, delta S. So this is a common equation, thermodynamics equation. So applying some of this, so two dependent variables, entropy and enthalpy, or enthalpy and entropy on time. Time is the independent variable here. All right, so delta H by delta T plus or minus delta S by delta T is equal to delta G by delta T. So that's my first equation. And the original equation is delta G. So now I'm going to come to the explanation. So integrating with respect to time between limit 0 to infinity. So this becomes H plus or minus entropy, enthalpy minus or plus entropy is equal to Gibbs free energy multiplied by time plus constant of integration, which is the difference of the limits, difference in the limits and difference of the limits, infinity. So the Big Bang theory, so enthalpy, it was all a ball. So enthalpy, hot ball. All the primordial elements, H and amino acids. So H enthalpy, infinity, all right, because it was so hot, millions of degrees of temperature, Kelvin, or degree centigrade too, plus or minus entropy. Entropy was infinity because an increase in disorder or is change in entropy, but entropy is disorder, total disorder. So this was all not in order. There was no universe. It was all a ball of fire. So infinity is equal to Gibbs free energy multiplied by beginning of the earth, day one. But there you have constant of integration, infinity. So infinity, and it was all in, day one, G plus. So Gibbs free energy. Maybe you could add infinity plus infinity, two infinities minus infinity. This goes to this side is equal to Gibbs free energy at that time. All right. So I'll just read from the internet what Gibbs free energy is and put it all together. Gibbs free energy is a thermodynamic potential that indicates a spontaneity of a process and the maximum work a system can perform at constant temperature and pressure. So, the rest is not applicable here for the regular equation, delta H minus T delta S. So, so thermodynamic potential and so spontaneous. It had to, explode and become the universe slowly. So that was a spontaneous thing that could happen. All right. So that was connecting Stephen Hawking to change in entropy and what he said about the universe. Stephen Hawking proposed that black holes possess entropy proportional to the event horizon area. Event horizon area is an infinite density, right? That's the definition of black holes. A concept crucial for reconciling the second law of thermodynamics with black hole physics. He argued this implies black holes have a temperature and emit Hawking radiation, leading to their eventual evaporation. Hawking also connected the arrow of time to increasing entropy, a necessary condition for life and the universe's evolution, suggesting that intelligent life can only exist in a universe with increasing disorder. And so hence, in present day time, time is equal to all the BCs plus 2025. You have the entry into, you could do the equation and see, changing enthalpy and see if it matches. So you have increasing entropy on a regular basis, or on a, see, it's very slowly. I mean, you don't see any universe changing, but the fact that it can, it's increasing entropy, so predicts that the what was that time, the that the arrow of time, that to increasing entropy, that adds up with what I have said. So arrow of time. So this stays the same. So as time, so you just the time factor changes. So time factor changes, and so you can see how much 2025 plus what was it, 550 BC, beginning of 3000 BC, wasn't it 3000 BC? So beginning of or was it 5000 BC? The Toronto Star, and I took Ambaraj quote, said the Chinese civilization and the Mesopotamian civilization came before the Indus Valley civilization and the Egyptian civilization, and I had argued with the Toronto Star editor. It never got published because maybe I was not accurate, but are they sure? All right, you have Persian civilization coming up all the time these days. There's these books on Project Gutenberg. Maybe they don't know the language, so they misinterpret things. So they, say, well, Persians came before the Greeks. Before the Greeks, I have Persian friends, right? Iranian friends from back of my graduate and work days in the Department of Chemical Engineering at the University of Toronto, and it's a real tall order, isn't it? They came before the Greeks and the Romans, and Persians. Who was the guy? I forget. Darius the third. Excellent. I think he came to India. He invaded India. Everybody invaded India. If you think about it, because saffron and everything is really expensive. Also, the temperature. It never had occurred to myself. I studied in an East Indian school. We never thought temperatures are conducive. You see, I mean, winters, but deserts, Middle East is always hot, and so things to grow things. But then they survive. They do well. All this, all the petrodollars, all the money from all their oil, so they can get soil and build stuff in their own neck of the woods. So, so time can change, and then you would have, you could put a figure, maybe about the Paleozoic era or the Mesozoic era, and see if this all works out. But one should not go back to the time of dinosaurs. That they were the scariest of animals after Jurassic Park, the movies. So I'll choose maybe beginning of Stone Age Man. Stone Age Man was when? After I have a Reader's Digest book. All right. Signing off, Gayatri B. Sitaram. Thank you.